What's up, everybody? It's Dan from SageMathTutoring.com, and I'm here with a video where I am covering a review sheet for some 8th grade math problems. So let's dive right in. Use cross products to determine whether the pair of ratios form a proportion. Okay, well, they would form a proportion so long as when you cross multiply, the products would equal each other. So 4 times 21 is, what's that, 84? And 6 times 14 is 60 plus 24, which is 84. So the fact that when I multiplied 4 times 21, I got 84. And when I multiplied 6 times 14, I got 84. Then these numbers match, so therefore it is a proportion. Okay, so the answer would be yes for that one. Problem number 16, they say solve the proportion. Solve the proportion. Well, in this case, it would be a matter of literally using cross multiplication. So if I'm going to solve that, we're looking at, 12 times b, which is 12b, equals 18 times 15, which is 270. And dividing both sides by 12 would give us 22.5. So that is how you do that one, unless I made a careless mistake. And in case my student's not clear, we divided both sides by 12 here. I think my student's pretty good at that. Looking at this one, you could add the x to both sides, right? I mean, that is a possibility. We could certainly add x to both sides. That would give us 4 equals 2x plus 6. At that point, we could subtract 6 from both sides, and that would give us negative 2 equals 2x. We can then divide both sides by 2, and that would give us x equals negative 1, which should be the answer to that one. All right, moving on, looking at problem number 18. First of all, you could always distribute that 7 right away, and as a result, you would end up getting 5n plus 7 equals 7n plus 7 minus 2n. We have like terms here, so you could always combine those. We have 5n plus 7 equals 5n plus 7. Now, notice how we have the same thing on both sides, so we would call that infinite solutions. All right, so that's the answer to that one. All right, looking at problem number 19, certainly we could distribute that there. We could distribute the 2, and as a result, we would have negative 4p minus 8 plus 8 equals 2p minus 2 minus 7p plus 15. We have like terms here, here. We have like terms here and here. And we have like terms there and there. So as a result, we could always, we'll just kind of bring it down here. We're looking at negative 4p. The minus 8 plus 8 is just 0, so we could kind of ignore that actually. We have 2p minus 7p, so that's going to be a negative 5p. And then we have this negative 2, this minus 2, and a positive 15, so that's going to be a plus 13. At that point, I think my student would understand we could add 5p to both sides. We would then get p equals 13. So that should be the answer to that one. Okay, looking at problem number 20. Solve that minus c for equals 0. Okay, so that's a literal equation, meaning you have a and b and c, but at the end of the day, we just want to get this x by itself. That's essentially what it's asking. So we want to get that blue x by itself. So we have a over b times the blue x minus c equals 0, and we want to get that blue x by itself, so that could be a matter of adding c to both sides. That would cancel that. We would have a over b equals c. Now notice how I got rid of the c first. I didn't do anything with the a over b, and the reason is because in order to get the blue x by itself, I at least want to get this term by itself. I want to get this whole thing by itself, and we just did that. So that puts us in this position here, and my student is watching this pretty good at this next part, I noticed, where At this point, we could get the blue x by itself by multiplying by the reciprocal of this fractional coefficient. Cancel, 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 cancel. We have the blue x equals, it's, c times b over a. I mean, the reality is there's really a little 1 underneath that c. So we could just kind of multiply straight across. So it's really just cb over a. All right, cb over a at the end of the day. So that's that one. Looking at 21. What the heck is even going on over here? Let's see. Saw the formula a equals 1/2. I'm going to assume that's 1/2. Obviously, the whiting out got a little too much there. And we want to solve for h. So we want to get this red h by itself. Well, clearly, if you have 1/2 b times h and you want to get that red h by itself, well, you're going to have to get rid of the b and you're going to have to get rid of the 1/2. Now, I say just do like one step at a time. Now, how can we get rid of the 1/2? Well, we can multiply both sides by the reciprocal of 1/2. And as a result of that, we would have really just 2a, if you think about it, because 2 over 1 is just 2. So 2a, this would be gone, and we would have b times the red h. Now, at that point, we're trying to get that red h by itself. Well, clearly, we could just divide both sides by b. So we would have h equals 2a over b. And that's that one. Problem number 22. If 1 centimeter equals blah, 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 use dimensional analysis to find 2.4 meters in yards, round to the nearest hundredth. So 1 yard is 36 inches. Okay, so that is a tricky problem where basically we want to know 2.4 meters is how many yards. Well, one thing we could do is we could figure out, well, what is the relationship between meters and yards in the first place? All right, if we could just figure out how many meters corresponds with how many yards in the first place, then we could kind of take things from there. So our first mission is to figure out, well, what is the relationship between meters and yards? Well, one thing we could do is we could start with the given information. We know that 1 centimeter apparently corresponds with 0.3937 inches. But at the end of the day, we're not really interested in the relationship between centimeters and inches. We're interested in the relationship between meters and yards, right? So my point is we don't want the word centimeters. We want the word meters. We don't want the word inches. We want the word yards, right? So therefore, we have to sort of set up this whole system here in such a way that the words that we do not want get canceled out, and eventually we bring to the table the words that we do want. Now, you might be wondering what the heck I'm talking about, and it's going to become clear as we go. Now, in order to get rid of the word centimeters, I'm going to force it to be down here, centimeters. Now, what do I know about centimeters? Well, apparently there's 100 centimeters for every 1 meter. Now, this word meter is one of the words that I already want, so I love that it's there. But I put centimeters down here because when there's this diagonal relationship, the word centimeters is going to cancel. All right, so we have that. Now, we also do not want the word inches, so I'm going to force the word inches to be here. And what do we know about inches? Well, we know that there's 12 inches in 1 foot, right? But at the end of the day, we don't want the word foot in there either. We want the word yards. Well, the good news is we know that there's 3 feet for every 1 yard. So at this point, we have the word yard, which is one of the other words that we want. And once we have the words that we want present in this train, we then can know that we're about to find out the relationship between meters and yards, because the reality is we put these words diagonal, centimeter and centimeter, so those words are going to cancel. The word inches is going to cancel with the word inches here because they're diagonal from each other. And we purposely put the word feet diagonal from each other as well. So the words are going to cancel. Notice how it's not the numbers that are canceling, but rather the words that are canceling. At that point, we can kind of treat this as just a matter of like fractions, like this fraction times this fraction times this fraction times this fraction. And therefore, we can multiply straight across. So we have 1 times 1 times 12 times 3. So that's going to be 36. Now we have the word meters left over. So we want that 36 meters, right? And then down here, we have this number times this number times this number times this number, and we have the words yards left over. Well, anytime you multiply 100 times a number, it's nothing more than moving the decimal place twice to the right. So this becomes 39.37 yards, okay, with a little box around it, right? And the green box around that, the blue box around the meters. So what we've done is we've officially figured out what the general relationship is between meters and yards. We know that for every 36 meters, there are 39.37 yards. So this is a really good way of going about it, in my opinion. So we have meters over yards. Now we can set up a proportion that will enable us to solve the rest of the problem. So we know that there's 36 meters for every 39.37 yards. We could set that equal to, now what do we want? We want to know what is 2.4 meters in yards. So we're looking at 2.4 meters, that goes on top, corresponds with how many yards, right? That's what we're trying to figure out. 2.4 meters corresponds with how many yards? Well, this is a proportional relationship. So at this point, we can then cross multiply, right? So we have 36x equals, and it's going to be cross multiplying here as well, right? It's going to be 39.37 times 2.4. I'll use parentheses to make it a little nicer looking. It's a disgusting looking 3, but you get the idea. And if you were to go through the motions with that, you would quickly realize that x 2.625. And that's going to be yards. All right. Now, how did I do that? You multiply these, and then you divide by 36, and then you're going to have your answer. So that's how you do that one. All right. Looking at other things. All right. 23. Company ABC earned a profit of $25,500 in 6 months. At this rate, how much profit will company ABC earn in 10 months? So we have another proportion. It's going to be profit as it relates to months gone by. Okay, profit as it relates to months. Now, apparently, we already know that we can get a profit of 25,500 every 6 months, but then you can set that equal to how much profit in 10 months. So once again, profit on the top, months on the bottom, profit on the top, months on the bottom. We already know what the relationship is. So at this point, we can cross multiply. So it's going to be 6 times x, which is 6x, and 10 times 25,500, which is 255,000. And dividing that by 6 would give us 42500. Okay, so that should be good. All right, looking at problem number 24. Freight train leaves the station traveling 60 miles per hour. 30 minutes later, passenger train leaves the station in the same direction, parallel, blah, 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 at a speed of 72. How long will it take the passenger train to catch the freight train? Okay, well, interesting. So in my opinion, this one's kind of different. This is a rate, time, and distance problem. So first of all, for my student watching, just know that rate, also known as the speed, times the time is going to equal the distance. Now, I have found that it's actually really helpful to bust out a table when it comes to rate, time, and distance problems, where you have these columns, and there's usually either two parts of the trip. Each row represents two parts of the trip, or in this case, it's going to be this top row represents one train, and this bottom row represents another train. This column represents the speed, this column represents the time, this column represents the distance. So freight train leaves the station traveling 60 miles per hour. Okay, so this will be train 1, and then there's passenger train, which is train 2. So the freight train is the train 1, and the passenger train is train 2. So the freight train leaves traveling 60 miles per hour, so you just fill that in, it's 60. 30 minutes later, a passenger train leaves the station in the same direction on a parallel track at a speed of 72. So this one's going 72. So we want to know how long will it take the passenger train to catch the freight train. So we have the freight train moving in this way, right? And then you have the passenger train, which is eventually going to catch up with the freight train. Now, in that moment, as you can see, the distance they both travel will be the same. All right, so that's going to be a crucial insight. You know, the freight train took off and the passenger train eventually took off as well. And then eventually the passenger train catches up with the freight train. And in that split second moment, the distance that they will have both traveled will be the same. However, I will say that the time spent on the tracks is a little bit different. So we're going to call the time, um, we're going to use the value t to represent time. Let's take a look. This passenger train leaves the station 30 minutes later, right? So let's say t represents how much time the passenger was on the tracks. In other words, how much time the passenger train was traveling. Now, if you think about it, the freight train left 30 minutes earlier, which means the freight train has been traveling for a longer period of time. In fact, the freight train has been traveling for 30 minutes longer than the passenger train has been traveling, right? Because if the passenger train left 30 minutes after the freight train already began traveling, well, that means the freight train has been traveling for 30 minutes more than the passenger train has been traveling. So that means that the time spent traveling for the freight train is t plus, I'll just say 30 minutes. Okay, t plus 30 minutes. But here's the deal. This is 60 miles per hour. So the time units that we're dealing with as it pertains to the speed is hours. So we can't say just 30 minutes. We have to say a half an hour. Okay, so it's 0.5. You can think of it as 0.5 of an hour, right? 0.5 of an hour, all right? Or 1/2 of an hour. So instead of saying t plus 30 minutes, I'm going to say t plus 1/2 or t plus 0.5. All right, hopefully that makes sense. Now, we already established that the distance is going to end up being the same, which is something that we could talk about in a moment. But in the meantime, rate times time equals distance, which means that we know for sure that the distance traveled by the freight train is going to be 60 times the time spent traveling, which is t plus 0.5. All right. The distance traveled by the passenger train is going to be 72 times t. Okay. Now, this is where that insight that we had earlier comes into play. We already know the distance that they traveled is the same, which means we could set these two things equal each other. So we can set these two things equal to each other. We have 60 times t plus 0.5 equals 72t. Distributing the 60 here, we're going to have 60t plus 0.5 of 60, which is just 30, equals 72t. At that point, let's subtract 60t from both sides. We're going to have 30 equals 12t. And then at that point, you can divide both sides by 12. You're going to have 30 divided by 12, which is really just, we can say 15 over 6 hours, okay, which is 2 hours and something. Now, it turns out that that is the answer, but you do want to be careful that to make sure that you're actually answering their question, right? So let's just double check the question. The question was, how long will it take the passenger train to catch the freight train? And here is the passenger train. How long did the passenger train travel on the tracks? Well, t hours, right? Well, we just found t. So that's 15 over 6. Now, 15 over 6 is really 2.5 hours, okay? And that's really, 2 hours and 30 minutes. So that is how I would strongly suggest doing that one, especially with that table and everything. So looking at this last problem here, we are looking at geometry. Container company wants to make cylindrical can with a volume of blah. The formula represents volume of cylinder. In this formula, V represents volume, R represents radius, cylinder's base, H represents the height of the cylinder. Solve for H. What height should the company make the can if the radius of the base must be 6? Okay, so we have V equals pi r squared times H. So V is volume, pi is just pi, that's approximately 3.14. R is the radius, and H is the height, in case my student's wondering what this sort of looks like. This is the height, and this distance right there, the distance between the center of the circle and the edge, that's called the radius. And the volume is just like basically how much stuff you can put in here. Okay, I guess maybe it's water or liquid. Volume represents how much actual liquid would go inside the container. Now, they actually tell us what the volume is, right? So they do say solve for H right here, which makes me think like, okay, well, they kind of gave us the formula and they did give us a couple numbers, but they did immediately also say solve for H. So what we're going to do is going to solve for H right away right now. All right. Now, how do you do that? Well, actually, you can kind of just divide both sides by pi r squared right away, because that would cancel these. And then next thing you know, you have H all by itself on the right, and you have V over pi r squared. Now that's going to actually turn out to be a helpful sort of variation of this red box equation. We have a new updated version of that equation that's going to be helpful. Now we want to know, what height should the company make the can if the radius of the base must be 6 inches? So apparently the R has to be 6 inches. So I'm going to go ahead and fill that in right now. We have V over pi times 6 squared. Okay. Now, what about this V? Well, they already told us what the volume is. The volume is 1188, right? So I'm going to write it over here. H equals 1188 over pi times, let's get this over with, 6 squared is really 6 times 6, which is 36. Okay. So that is pretty much the answer. I think it's possible the teacher might want us to reduce this, certainly, but at the same time, I don't know if the teacher wants us to leave pi in there. So let's see, 1188. I'm curious to see if that's actually divisible by 36. Let's see. It actually is. Yeah, yeah. So these numbers, these can reduce because the reality is 1188 divided by 36 is actually 33. So you could think about this turning into a 33 and this turning into a 1. And if we were to do it that way, then the final answer could be H equals 33 over pi. Now, for my student watching, just know that pi is approximately 3.14, but it's approximately 3.14, right? It's not exactly 3.14, which makes me sort of tempted to leave the answer in this form, because by just writing the pi symbol underneath the 33, this is actually the most accurate way of representing the answer. All right, so hopefully that makes sense. Anyway, for everyone watching, hopefully all this makes sense. If I made any careless mistakes, let me know. The process I presented as, the means to solve each of these, I definitely feel confident about that for sure. But of course, there's always the chance that I made a careless mistake somewhere, so just let me know. But anyway, for my student watching, good luck. Maybe practice these again. Make sure you get them. Make sure you get all of them, and good luck on the test. All right. So for everyone, I will see you later. Bye.